So, good morning, everyone. My name is Man Gandhi, ID number 22DCS020. I am studying at Charles University. So, my topic of MCO is bus architecture. Here is the architecture of the bus in which we have used memory unit, address register, program counter, data register, accumulator, input output register, temporary register. Bus architecture. The three-axis select line determines which register is allowed to write to the bus at the given time. Recall that only one write at a time is allowed. Registers have load input signals that tell them to read from the bus. If the registers are smaller than the bus, then unused bits are set to 0. Some registers have additional input signals. Increment and clear. Bus architecture. Memory has read-write input signals that tell it when to take data from the bus and send data to the bus. Memory addresses are always specified via the address register. An alternative is a two-way bus system. One address bus, one data bus. Results of the all ALU are always sent to the accumulator register. The ALU is the only way to set values into the accumulator except for the clear and increment control lines. Inputs to the ALU come from the accumulator, data register, input register. The E output from the ALU is the carry out bit. Many architectures pack this into the register with bits such as the overflow. Some pairs of micro-operations can be performed in a single clock cycle. The key is to make sure they don't both try to put the data on the bus. Consider the register transfer language statement, accumulator to data register and data register to accumulator. This is allowed since the data register micro-operation uses the bus while data register micro-operation does not. Instructions. We said previously that there are two parts to an instruction, opcode and operand. Realistically, the two parts should be called as opcode and everything else. Three basic types: those that reference memory operands, those that reference register operands, those that reference IO input-output device. Again, this is only for the fixtures architecture in the textbook, but you will find similar categorization in real architectures. Memory instructions. There are 14 instructions in this class. 7 direct memory address forms, 7 indirect memory address forms. Here is the figure of the address registers in which 0 to 11 bits are address, 12 to 14 are opcode, and 15 is the I. I is equals to 0 means direct memory address and I equals to means the memory address. Here is the memory instruction table, here in which a symbol, hexadecimal code and description is given. For example, symbol is AND. If I is equals to 0, then its hex code is 0xxx. If I equals to 1, and hex code is 8xxx, and description is memory and AC. Similarly, add, LDA, STA, burn, BSA, IZS. Register instructions. There are 12 register instructions in this class. They can use the operand field to specify the register and type of operation since no memory address is required. Here is the table of the register instructions and its hex code and description is also given. Register instructions continues. Similarly, the input output instructions. There are 6 instructions in this class. They can use the operand file to specify the exact operations since no memory address is required. Here is the table of the input output instruction with description and hexadecimal code. Instruction decoding. The control unit elevates bits 1512 to determine the instruction format. At first glance, it appears that there can be only 8 unique instructions since the opcode resides in 4 bits. But additional instructions are created through the use of the 1 bit and unused bit in the operand field. Thank you.